So, welcome students in the series of lectures that we are doing. We have gone through the part which is primarily referred to as pure geometry. Now, what we have to understand is that thinking in geometrical terms on occasions may be a bit demanding. So, we would like to come up with some methods which are bit algebraic in nature, so that the normal operations that we do based on certain functions that we will define and you might possibly be aware of, would be helpful in dealing with problems. So, in that series, one of the things that we must be reasonably aware of is trigonometry. A bit of it you would have covered in your school classes, that in a right angle triangle we define the legs as perpendicular base and this side as and the side opposite to 90 degrees hypotenuse, and you know that sine theta is p by h, cos theta is b by h, and tan theta is p by b. This is also 1 upon cosec theta, one upon sec theta, and this is 1 upon cot theta. The identities that you must be aware of are sine square theta, cosec square theta is 1. So, I hope all of you are aware of these things. We have to know a bit more trigonometry, so that we are comfortable in dealing with problems, especially of triangles and also of higher degree polygons. Even in our previous discussion, we saw how in radius, circumradius and side of a regular and sided polygon were connected. So, these things in that scenario turns out to be of great help. Today what we are going to do is we are going to extend the definition of sine cos to angles which are beyond 90 degree, because angles of a right angle triangle barring this angle is going to be an acute angle. So, post 90 degree, how do you define sine cos? So, what we say is that if we take a unit circle, okay, and if we are moving counterclockwise, the measurement is positive. If we are moving clockwise, the measurement is negative. And if you move an angle theta, you reach a point P whose coordinates are x and y. So, what we say, x is cos theta and y is sin theta. Okay. So, even if when you are at this point after moving this much distance, this point will have some x and y coordinates. Okay, this too will satisfy what is x coordinate will be cos theta, y coordinate will be sin theta, and it is in consonance with the definition of sine cos that we do. This is x, this is y, this is 1. Base upon hypotenuse is cos theta, perpendicular upon hypotenuse is sin theta, tan theta would be y by x. So, from here you can understand that x coordinate can at max be 1 and least be -1. So is the case with y coordinates. Okay. So cos theta always lies from -1 to 1 and sin theta always lies from -1 to 1. Okay. The identities that we have gone through, they remain the same. You can understand that when you reach this point, tan theta is not defined because x is 0. When you reach this point, cot theta is not defined, okay, because y is 0. So sin, cos are defined for all theta. Tan is not defined for, say, this is 90 degrees, then 270 degrees, and then we can move on like that. But I am not getting into that typical part. Our primary aim is how will we use it in geometry. So I am not getting into the proper definition and stuff like into too much details. The purpose of going through trigonometry here is to let us be comfortable with so that we are comfortable with the problems that we are required to solve in trigonometry. Especially solution of triangles we will be using. So a bit of trigonometry is did there. That is the sole purpose of going through this, not per se studying trigonometry. Now, when we talk of allied angles, okay. So what we say is sine, I hope you are aware, sine 90 minus theta is cos theta. Cos 90 minus theta is sin theta, and thereby tan 90 minus theta is cot theta. Okay. Now, if we talk of, say, sin 90 plus theta and stuff like that, how do we get to know it? See. Suppose this is theta, add 90 to it. Okay. Now you can very easily see this is 1, this is 1, this is 90, this is 90 minus this is theta. So these two triangles are congruent. So if this side is x, opposite to 90 minus theta, this side is x. This is y, so this would be y. So what are the coordinates at this point? If this is x comma y. Okay. So what is sine? Can you think what is sine 90 degree plus theta? Y coordinate. Y coordinate is x, and what is x? Cos theta. This is cos theta. Cos 90 degree plus theta will be nothing but y coordinate, which here is cos 90 degree plus theta will be nothing but x coordinate, which here is minus y. Minus y is minus sin theta. Simply for other allied angles, we can extend it. Say sin 180 degree minus theta, cos 180 degree minus theta. So how are you going to do that? Say, let me draw the figure here. Okay, this is theta, this 2 is theta, and these two triangles therefore are congruent. So if this is x comma y, this is minus x comma y. So sin 180 degree minus theta would be sin theta, cos 180 degree minus theta would be minus cos theta. Just by congruency we look at it. tan 180 degree minus theta is therefore minus 10. Generally, this one would be sufficient, okay. But okay, for the sake of completion, let me tell you this also. Pi plus theta, this would be minus x comma minus 1. So, this is pi. So, sin pi plus theta, that is sin 180 degree plus theta is minus sin theta. Tan 180 degree plus theta, you can say minus minus gets cancelled out. Okay. Similarly, I can make you prove also the relation between say 270 degree minus theta, 270 degree plus theta. I am simply writing it, okay. Fine. And then if you talk of say this minus theta or 360 degree minus theta. So, sin 360 degree minus theta is minus sin theta, which is sine of minus theta. Cos 360 degree minus theta is cos theta, which is cos of minus theta. So, these are trigonometric ratios of allied angles. So, we need to just keep in mind, and we should at the initial level you have to practice a lot. I will ask you to solve initial exercises of trigonometry SL only, so that you are well aware of this stuff, because without practice there would be so many formulae that you will not be able to recall at the appropriate juncture. Not much of trigonometry would be needed. Elementary trigonometry expression would be needed for what we have to do. At least this part we must know, this part we must know, okay. 90 plus theta up to 180 degree, because mostly we will deal with situations of a triangle or a quadrilateral. So, it is hardly the case that angle exceeds 180 degree, okay, because we generally deal with convex polygons. Moreover, post 360 degree you can understand that if I move theta plus 360 degree, I will reach the same position. So, for any trigonometric ratio, if you add 360 degree, that will be equal to the trigonometric ratio itself, where n is an integer. Okay. So, any multiple of 360 degree, suppose somebody wants to find sine 390 degree. So, it is which is nothing but. Also from this you are able to understand that in second quadrant x coordinate is negative, cos is negative, sine is positive, cos is negative. Here sine is negative, cos is negative. Here sine is negative and cos is positive. Okay, so therefore people remember it here all sine, tan, cos, all sine tan cos. Add sugar to coffee. Quadrant wise, which one is positive, which one is negative. So, what we do is, suppose somebody asks you to find cos 120 degree. What we do, this is cos 90 degree plus 30 degree. Okay, what is our formula? Cos 90 plus theta is minus sin theta. So, this is somebody is asking you sin 135 degree. So, sin 90 degree plus 45 degree. So, this is cos 45 degree. This is 1 by root 2. Okay, what we want is that over a period of time you are able to remember it and recall it as and when required. More often than not, the purpose for which we are reading this part is more often than not our discussion would be confined to angles which are less than 180 degree, because as I have told you, our angles are going to be angles of polygon, angles of triangle, okay, and all those angles, as you can see, is less than 180. Most of the things that we study are are angles of polygons which are convex polygons mostly. Fine. Okay. Now, after this, I am going to tell you lot of formulas. So, it is my sincere request that please solve SL only trigonometry part 1, so that you are well versed with the formula. Otherwise, you will find it very difficult to remember them. It's very, they turn out to be very cumbersome. So much expressions are involved, and we need to switch from one to other very swiftly. We are generally expected to be very fluent in it. Okay, but the purpose of us going through that is to know a bit of to use it in solving problems of geometry. Okay, so I will tell you just a plus b and 2 theta formula, and then I will come to solution of triangle part. Okay, trigonometry in itself involves a lot of things, but we are not getting into it. Okay. Now, compound angles is formulae for stuff like sin a plus b and cos a plus b. So, what we do is that suppose there are various ways to come up with it. Let me draw a very beautiful proof in which we use sides of rectangles to justify the expressions. Okay. Now, consider this triangle, okay, a right angle triangle. This angle is a plus b and its hypotenuse is 1. Fine. So, what is this side? What is this side? Cos a plus b. Okay. Now, what I am doing is, from here, say, draw a line which is making an angle A. Sorry, not drawn proper. Perpendicular lines, okay. Okay. So, if you remember, if this is a plus b, this is 90 minus A minus B. So let this angle say for simplicity be B. So what we do is that we complete this rectangle. So if this is 1, what is this? This angle is going to be A. So if this is B, this is 90 minus this angle is A. Okay. So this is cos B and this is sin B. Okay. Now if this is cos B, what will this side be? A. This is cos B, cos A, cos B. Is it? Hypotenuse is cos B. So base is cos A, cos B. What will perpendicular be? Sin A, cos B. This is sin B. So this is sin B, cos A. And this is sin A. Now it is easy to see sin A plus B is sin A cos B plus cos A sin B or sin B cos A. What is cos A plus B? Cos A cos B minus sin A sin B. Tan A plus B if you want simply divide these two. Okay, if you divide these two, what do you get? This upon this, and divide the whole thing by cos A cos B. So in the denominator, what do you get? One minus tan A tan B. And if we divide this by cos A cos B, sin A by cos A tan A. Divide by cos A cos B, sin B by cos B tan B. So tan A plus tan B upon 1 minus tan A tan B. Now sin A minus B. Simply replace B by minus B, cos minus B is cos B, sin minus B is minus sin B. So sin A cos B minus cos A sin B. Cos A minus B is cos A cos minus B, which is cos B, sin A sin minus B. So this becomes plus. And therefore tan A minus B is tan A minus tan B upon 1 plus tan A tan. Other formula that we derive is that if you multiply these two, sin square A cos square B cos square A sin square B. So this is sin A plus B into sin A minus B, sin square A minus sin square B, and simply cos A plus B into cos A minus B. Cos square A minus sin square. And I do the same exercise again. Again, as I have been telling you right from the beginning of this lecture that trigonometry will involve lot of formulae. At least this much we must be aware of. Okay? Fine. Now, we will just move to double angles and that's all. Okay? We will not get involved in too much of other formulae, pure trigonometry stuff. Okay? One thing that in a triangle, if A, B, C are angles of a triangle, none of which is show that we will prove it here and we are required to remember it. So, what we know is sum of the angles is pi, angles of a triangle. So, what do we get? Pi minus c, and now we take tan both sides. So, tan A plus B is tan pi minus c. Tan A plus B is tan A plus tan B tan pi minus c is minus tan c. Simply cross multiply and get the result. Okay. So, in a triangle, sum of angles of the tangent is equal to product of the angle of the tangents. Product of the tangents of the angle, sorry. And sum of the tangents of the angles is equal to product of tangents of the angle. So, please keep this in mind. Okay. Now, if we move ahead to multiple angles, sin A plus B we know. So, what will be sin 2A? Can you make it out? Put A here. So, sin 2A is sin A cos A cos A sin A, that is 2 sin A cos A. So, sin 2A is 2 sin A cos A. Put B as A here, what you have? Cos 2A is cos square A minus sin square A. We can also write sin square A as 1 minus cos square A. Okay. So, cos 2A is cos square A minus sin square A, 2 cos square A minus 1, 1 minus 2 sin square A. Tan 2A upon 1 minus tan square A. Also, remember this 1 plus cos 2A is 2 cos square A. 1 minus cos 2A is 2 sin square. Okay. So, up to 2 theta if you are able to recall, say, or 3 theta also I may tell you. 3 theta you can simply write B as 2A and then we have formula for them also. Okay. Let me tell you that formula also. Okay. Sin 3A is sine 2a plus a. This is sine 2a cos a. So 2 sine a cos a. This is 2 sine a so what we have sine 3a is 3 sine a minus 4 sine 2. What is cos 3a? Simply do it. I am finally writing the formula. Sine 3a cos 3. We can also write tan 3a, tan 2a plus a and then, okay, why leave it? Similarly, you can find tan 3a by writing tan 2a plus a. This is 3 tan a. You can understand how many formulae are there, okay? So, please practice it. The best text is definitely SL only. If you use SL only, you will get lot of problems based on a single formula. It gives you 3-4 formulae, it gives you 20 problems. I am deliberately not using the uh, not taking up lot of problems, because my purpose is not to teach you trigonometry. The purpose is that while solving problems of geometry, we will need some trigonometry and we are just adding a bit of flavor in it. Okay. So, that is the sole purpose of what we are doing today. This might feel very burdening and boring to you, and therefore, I am saying that please go through the questions and solve them on your own, so that you are relatively well versed in terms of the formulae. We are expected to know sin a plus b, cos a plus b while dealing with properties and solution of triangles. Okay, so that is the purpose I have taken up this. Otherwise, we could have done it some other way, because trigonometry, reaching till this point when we normally teach pure only trigonometry, will take 5-6 lectures. But here the purpose is simply to introduce you to the formulae, and thereafter when we actually go to the part where we will use trigonometry to solve questions of geometry, we must at least not be found unawares. What is this? So, that is the sole purpose of this. Okay? So, just know the expressions. Okay? Now, let me take up questions. Like say, find the value of six sine 10 degree. So, what will this be? Take 2 common, this is what is this? 3 sine theta minus 4 sine cube theta, sine 3 theta. This is simply 1. Okay. Some more formulae that we need to know are formulae from this point. This is sine a plus b is this. Now, if we add these two, 2 sin A cos B, sin A plus B plus sin A minus B. Product to sum. If we subtract, here also you can add and subtract. So, some more formulas are okay. Some more formula says that 2 sin A cos B. How are we getting it? Adding sin A plus B sin A. 2 sin A cos B, sin A plus B plus sin A minus B. So, changing product to sum. Two cos A sin B. Now, in cos A plus B is cos A cos B minus sin A sin B, cos A minus B is cos A cos B plus sin A sin B. See, if you add these two, what do you get? 2 cos A cos B. The 2 cos A cos B. Fine. And from here, what generally people do is that if we say A plus B is C, we write sin C plus sin D is 2 sin C minus D by A is 2A is C plus D, 2B is C minus D. Sin C minus sin D. You get 2 cos cos C plus cos D. And cos C minus cos D. So this is, you see this is just the other way around, okay? It is minus 2 times sin C plus D by 2. So now you can see how do you change product to sum or difference to product as the need be. So these are the formulae I am telling you, okay. 4, 4, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, these 20 expressions you need to know, and initial part, this is something that I told you. This one, this is tough. Okay, this also we need to remember. So today you have seen that we have used lot of formulae, okay. And this one also needs to be remembered, okay. We need to remember it. Okay. So after going through all these formulae, let me tell you the purpose for which we were going through it. These 45 minutes may have been bit demanding, bit torturous to you, but I am telling you that if you remember these formulae, they will be of great help and will be beneficial in solving the problems that you encounter, because as we see, geometry requires a lot of ingenuity. Here, once we know the expressions, we are able to use sine, cos and stuff like that, sine, cos, tan and stuff like that to deal with the situations in hand, especially in case of triangles and quadrilaterals, higher degree say polygons of say 5, 6 sides, pentagon, heptagons, hexagons stuff. That also we generally see we do it by reducing it to appropriate triangles, appropriate quadrilaterals. Fine. Now, in heights and distances also they are of great use. You would have gone through heights and distances. I am deliberately not getting into it. Okay. So, we are going through sine law and cosine law. Okay. So, in sine rule what we say? In a triangle, A upon sine A is B upon sine B is C upon sine C, which is 2r. This is called extended sine rule. R is circumradius. I hope you remember small ABC. Okay. They represent sides. What is A? A is BC. We went through all this when we were dealing with trigonometry. Okay. So, it is very easy to prove if you look at it properly. You draw this altitude. So, what is AD in this right angle triangle ABD? C sine B, and in it 8 CD it is. So, C by sine C is B by sine C. Similarly, draw one more altitude and get to it. How do you get to 2r? If this angle is A, angle at the center is going to be 2A. This is A, this is A, this is R, this is R. So, this is R sine A and this is R sine. So, this is nothing but length of side BC. So, BC, which is A, is nothing but 2R sine. A by sine A is 2R. So, while dealing with questions of triangles, this is of great help. Okay. You do come across lot of things where sine rule and cosine law on most occasions is sufficient to deal with the problems that we generally encounter. So, I would request all of you to be well versed in sine law, and after this class, maybe in the next, we will take up cosine law. So, today we will confine most of our discussion to sine rule only, all of our discussion. Let us introduce cosine law in our next class. Okay. Now, how do we deal with the situation of sine rule. Whenever you are solving problem of trigonometry which involves say angles which are not nice, then we can use sine or cosine law. For example, if I say, let me start with this problem like this question. In a triangle, A is equal to R into find perimeter or find area of triangle if its largest side is 4 units. Symbols, these are all sides, this is circumradius. Okay. So, this is AR. What we have read? A is 2R sine A. So, A upon R is 2 sine A. Okay. So, A upon R so this is 2 sine A, and by AM GM we can say B plus C is greater than equal to 2 root BC. AM is greater than equal to GM. All these are positive numbers as we are dealing with sides of the triangle. So, 2 sine A is, you can see, root B by C. So, sine A turns out to be, this implies sine A is 1 and B is equal to equality holds. So, what all in all we have an equilateral triangle. Largest side is 4. This is 45 degree. So, these sides are 2 root 2, 2 root 2, and I think other will follow. Area is a very trivial thing. Half eight by 2, 4, isn't it? Area is 8 by 2, which is 4. From sine rule also you can possibly understand, as we did the proof here. C sine B. C sine B is the altitude and this is base. So, area is half AC sine B or half AB sine C, or what you can write further, AC AB BC, half BC sine. Fine. This is how we have used sine rule. Now, in a triangle, if somebody says, see, A, B, C are proportional to sine A, sine B, sine C. So, if sides are in AP, sides of a triangle, if they are in AP, then sine A, sine B, sine C, they too are going to be in AP. Okay. Let me say, in triangle ABC, in triangle ABC, altitude from vertex A has length ABC upon B square minus C square. If angle ACB is 23 degree, find angle BAC. Okay, so just now we saw the length of altitude from vertex. That is why I have always told you, remember how did we initiate the proof, how we prove things. What is the length of altitude? C sin B or B sin C, as you wish. Okay. So, length of altitude, from vertex A. Say C sin B. So, sin B is AB upon, now either we write everything in angles or everything in sine. Either we change here as this as B by 2r. Either we do that or we change this as A is 2r sin A, B is 2r sin B upon 2r sin B whole square minus 2r sin C whole square. So, sin B is sin A sin B upon sin square B minus sin square C. Now, we have read this formula, sin square A minus sin square B, sin A plus B into sin A minus B. Okay. So, this is sin A upon sin B minus. So, sin B gets cancelled out. What we are left with is 1 is equal to sin A upon sin B plus C. So, what is B plus C? Pi minus A. Okay. And what we have read today? Sin 180 degree minus theta is sin theta. So, this is why see, this is how formulae are required to be used. These two are equal. So, sin B minus C turns out to be 1. It is an obtuse angle triangle, meaning thereby B minus C is 90 degree. Okay. So, angle C is 23 degree. So, B is 113 degree. C is 23 degree, 136 degree. So, what is angle A? 44 degree. Okay. So, we were going through those things in trigonometry for the simple reason that we, when needed, we are able to apply the formula. As such, the purpose was not to go through trigonometry, because it is a helping tool, it is an auxiliary thing. That is why we have gone through it. We get some good problems in whenever you have to introduce a variable or your own, whenever you are into solving triangles, sine rule is of great help, more often than not. Whenever you are in doubt in so far as triangles are concerned, sine rule generally is of great help. This has been my experience. Let us take one more problem, last problem of today, so that you are able to do some practice of sine rule at your home post this lecture, and of course remember the formula of trigonometry. Make it a priority. We will give ample time to sine, cosine law and other stuff related to solution of triangle. Unfortunately, we were not able to give that much time to trigonometry, but to remember the formulae, it is necessary that you practice them. So, to practice them, the standard text for last close to 1.5 centuries is S.L. Dhoni, written in say 20th, rather 19th century. Okay, 1880, still is a classic and extraordinary text. Now, sine rule, problem, okay, AP and sine rule, okay. Up, suppose I say 3 theta, formula of 3 theta would be needed now. In a triangle, A plus C is 2B. Let me ask you a simple question. Find the value of very simple problem, okay. Sorry. Okay. So, how do we solve it? 2r sine A, you can see 2r will appear everywhere and it will get cancelled out. So, sine A plus sine C. Sine C plus sine D. 2 sine C plus D by 2 cos C minus D by 2. And also we will use sine 2A is 2 sine A cos A. So, sine A is 2 sine A by 2 cos A by 2. If here we use A, this is A by 2, A by 2. Okay. So, sine A plus sine C is 2 sine A plus C by 2 cos is 2 times 2 sine B by 2 cos B by 2. Now, what is A plus C? A plus C is sine now sine pi by 2 minus B by 2 is cos B by 2. into cos A minus C by 2. This is equal to 2 sin B by 2. So, cos A minus C by 2 upon sin B by 2 is 2. Okay, so let us complete today's lecture by a very simple problem. Cosine law, very powerful tool, and sine law put together would be of great help insofar as solving problems are concerned. Okay, and it is my sincere request to all the students who have watched this and hopefully gained from it to practice formulae of trigonometry. Just don't pen it down and try to remember. Okay, do problems. When we use a formula twice or thrice, pen it down on your own, you tend to realize what are the situations when they will be used. Okay. So, thank you very much for motivating us to continue this series. Okay.